Okay, today we're diving into a real head-scratcher on Mars. It's a geological puzzle that might just rewrite the timeline for how long the planet could have been habitable. See, NASA's Curiosity rover stumbled upon these bizarre web-like patterns, and they're hinting at a past that's way wetter and way more life-friendly than we ever thought. So, you ready? Let's follow the clues.
So, when you look down from orbit, the surface of Mars is just etched with these incredible patterns. They almost don't look natural, you know? It's like this massive network of veins stretching for miles and miles across that classic red dirt. We're talking huge, and honestly, where they came from, a total mystery.
And that right there, that's the billion-dollar question, isn't it? I mean, Mars today is a freezing desert, so how in the world did these enormous, web-like things even form? To get to the bottom of it, NASA had to send a detective right to the scene of the geological crime.
And that detective? None other than the amazing Curiosity rover. But look, getting a close-up view of these things was anything but a walk in the park. This was an incredible challenge. The rover had to cross some of the gnarliest terrain it's ever seen. And let me tell you, that journey pushed the drivers back here on Earth to their absolute limits.
Just try to picture this for a second. We're talking about a robot the size of a small SUV, weighing almost a ton, and it had to thread the needle, picking its way across these sharp, rocky ridges that were barely wider than the rover itself. I mean, one wrong turn, one slip, and the whole mission could have just been over. No pressure, right?
One of the rover drivers, Ashley Stroop, talked about what it felt like. She said it was almost like driving on a highway, but then you have to drop down into these hollows where you have to be super careful not to slip. Can you imagine? It's just an unbelievable feat of remote-controlled driving from millions and millions of miles away.
So every single move had to be planned out with painstaking detail. The team back on Earth would scan the terrain ahead, they'd plot a super precise path right across those narrow ridges. Then they'd carefully drive down into the hollows, trying like heck not to get stuck in the sand. It was basically a high-stakes driving test every single day, just on another planet. Okay, so after that absolutely epic journey, what did our little detective, Curiosity, actually find? Well, once it got on the ground and got a good look, the view was, honestly, it was even weirder up close than it was from space.
Right, so these things that looked like spiderwebs from orbit, turns out they have a name, boxwork formations, and they're not webs at all. What you're seeing are these sharp, low ridges of really hard rock that are standing out from the ground, with these scooped out, sandy areas in between. So think about it this way. It's not about what was added, it's about what was left behind after ages and ages of wind just blasting everything else away. Now what's wild is that we actually have boxwork formations here on Earth, but they are nothing like this. Here they're tiny, maybe a few centimeters tall. You might find them in a cave. But on Mars, whoa, these things can be up to 6 feet tall. That massive difference in scale was a huge clue for scientists that whatever made these was a totally different and way more powerful process.
So the leading theory went something like this. Way back in the day, groundwater flowed through all these cracks in the rock. As it flowed, it left behind minerals that acted kind of like cement, making the rock around those cracks super hard. Fast forward a few million years, the Martian wind comes along and just carves away all the softer rock around it. What's left? Just those hardened ridges. And sure enough, when Curiosity got there, it found the fractures right in the middle of the ridges, just like the theory said. So, case closed, right?
Well, not so fast. The groundwater idea was a really great start, but when Curiosity started looking closer, it found something that just didn't fit. A new clue, one that pointed to a story that was way more complicated and a whole lot wetter.
See, the rover spotted these little bumpy textures on the rocks called nodules. Now, nodules are a classic sign of past water, but here's the twist. They weren't all clustered around the main cracks where the first round of groundwater should have been. No, they were all over the place, on the walls of the ridges, down in the hollows. That was a total game changer. It suggested that this wasn't just one event, it was probably multiple later waves of water that soaked the entire area.
Okay, so to figure out this new puzzle, Curiosity had to switch hats. It was done being just a driver and a photographer. It was time for it to become a full-blown geologist. Time to fire up the advanced science lab it carries around inside its belly.
So the rover got to work. It used its drill to collect 3 powdered rock samples from 3 very specific spots. One from the very top of a ridge, another from the bedrock down in one of the hollows, and a third from a spot kind of in between. Each one of these samples was like a tiny time capsule of Martian history, just waiting to be cracked open.
And you know what? The results were pretty amazing. The ridgetops, they were full of clay minerals, and clays usually form where there's a lot of water. But the hollows down below, they had carbonate minerals, which can actually form in drier conditions. Finding these two different kinds of minerals, both tied to water but in different ways, in different places, it proved this area had a really complex history, with water coming and going and changing things over time.
But then, for the most interesting sample, the team did something really special. Something they almost never do on Mars. They used a technique called wet chemistry. Basically, they mixed the rock powder with a liquid solvent. Why? Because this lets the rover hunt for organic compounds. You know, the carbon-based molecules that are the literal building blocks of life. So just like that, this geological investigation became directly linked to the search for life itself.
So what does this all add up to? When you take all the clues, the giant ridges, those weirdly placed nodules, the different types of minerals, and you lay them all out, a brand new picture of ancient Mars starts to take shape.
And here's the verdict. Water wasn't just some brief visitor that passed through. Nope. All this evidence suggests that the groundwater system here was huge. It was complex, and it stuck around for a very, very long time, way later into Martian history than scientists ever thought possible for this part of Mars.
Just listen to what mission scientist Tina Seeger said about it. She said, the water needed for life could have lasted much longer than we ever thought, just from looking down from orbit. This totally changes the timeline.
And really, that's the big takeaway here. If you have liquid water for a longer period of time, you have a much bigger window of opportunity for microbial life to show up and, stick around. These Martian spiderwebs, they're like a ghost's fingerprint, pointing to a habitable world that may have lasted long after we assumed it was gone.
Which leaves us with one last, really tantalizing thought. If the water lasted longer than we ever thought possible, what else might have?